From the ground, clouds appear as weightless, ethereal tufts of cotton. We watch them drift and assume they're as light as they look. This perception is largely a result of distance. Because these objects are thousands of feet away, our eyes fail to register the actual scale of the physical matter moving above us. When we apply the laws of physics to a standard cumulus cloud, the visual illusion disappears. These are not light vapors. They are entities with a total mass of 1 million metric tons. This creates a physical contradiction. If it is that heavy, gravity should pull it down. We have to ask why a 1,000,000-ton mass stays suspended rather than falling to the ground. To understand how the sky functions, we have to move past visual assumptions and look at the mathematical measurements that define the atmosphere. To weigh a cloud, we first have to define its boundaries. Since clouds vary in size, we'll start with the dimensions of a typical medium-sized cumulus cloud. This standard cloud occupies exactly 1 cubic kilometer. Within this space, the mixture of air and water droplets has a density of 1.003 kilograms per cubic meter. Scaling that density gives 1 billion cubic meters, multiplied by roughly 1 kilogram per meter. The result of this calculation is 1 million metric tons. That is the total mass of the air and water currently drifting overhead. If we were looking for a terrestrial comparison, that is exactly the same weight as 200,000 adult elephants. This means that 1 million tons of physical matter is currently hovering directly above us. This leads back to the central problem. Gravity pulls on a 1,000,000-ton cloud with the same intensity it pulls on anything else. The cloud remains airborne because of relative density. Its ability to float depends entirely on how its weight compares to the weight of the air around it. The surrounding air is roughly 0.4% denser. Because this clear air is tightly packed, it behaves like a physical support. By the mechanism of buoyancy, this denser air pushes upward with more force than the cloud pushes down. The cloud stays in the sky because it is resting on a substance that is heavier than itself. Atmospheric buoyancy ensures that any object, even one weighing 1 million tons, will float if the medium it is submerged in is denser than the object itself. To understand this properly, we have to look past the white droplets and focus on the invisible gases that fill the sky. A steel cargo ship floats because it is less dense than the salt water it displaces. A cloud stays aloft for the exact same reason. It is less dense than the air it displaces. This requires us to view the atmosphere as a fluid. It is not an empty space, but a medium with physical properties, similar to the ocean. The air around us is a mixture of nitrogen and oxygen molecules packed tightly together. This gas has its own significant weight and exerts constant pressure on everything within it. The 1,000,000-ton cloud overhead is continuously held aloft by the sheer weight of this invisible ocean of air. When we look up, we are seeing the physics of a heavy, active ocean. We are simply standing at the bottom of it.